right, so we have talked about nth roots, we have talked about rational exponents, and now we are going to take both of those things and we are going to solve radical equations. So just one learning goal for today: I can solve equations involving radicals and identify extraneous solutions. Now, please do remember that radicals are also fractional exponents. So you're not always going to see the radical in these equations. Sometimes it's there in the form of rational exponents, fractional exponents. So our whole goal with radical equations, which again includes equations with fractional exponents, is to eliminate the radicals completely. So we have what you would probably consider a normal polynomial equation. So you really already know how to do these because we have solved equations involving square roots, and we're going to apply the same principle to these nth roots that we did to square roots. You should know that the opposite of taking a square root is to square both sides. So if you had the x underneath a square root, you just took the second power on both sides. The square root and the second power canceled each other out. The same idea is going to follow with all our other roots that we've learned. So the opposite of taking a cube root is to cube both sides. The key, so I'm going to put a star here, is the exponents should be reciprocals of one another. So remember that a cube root is a 1/3 power. So if you take the reciprocal of 1/3, it's 3/1. So that is why we take the cube of both sides, because the 3 undoes the 1/3. So here's some hints to follow, because all of the equations don't look exactly the same, and there are two different situations that we're going to look at. The first is when you have a single radical or fractional exponent, so just one radical in the entire thing. If that's the case, you want to get the radical term alone first and then take the appropriate power on both sides. So always remember here, if there's one radical or one rational exponent, get that term alone first, then take the appropriate power. You will have some equations where there are two different radical terms or fractional exponent terms. And if that's the case, if there are two, you have to get them on opposite sides and then take the appropriate power. And I'll show you why when we get to one of those examples. Now, the part that is new and that can be a little tricky is that since we have variables under our radicals, not all the solutions that we come up with will actually be in our domain. This is one reason why we went through domain in the first couple sections again. Because sometimes when you get rid of the radicals and you solve what's left, you come up with an answer that actually, when you plug it back into the radical, would give you an imaginary solution, which we're not allowed to have. So once we find solutions, we have to check them. We call the solutions that don't work extraneous solutions. You have to check for them in every problem. So after you solve, you have to check every single time, because if you find an answer and it's really extraneous, yes, you lose points for not crossing it out, for not knowing that it's not part of the domain. All right, so let's jump right in and see what we can do here. So in this first one, in A, we have just a single radical. So that means we're going to follow our first little bullet point here. If there's just one radical, we get the radical term alone first. So that means I'm going to move this radical over to the other side. So add 4th root of x on both sides of the equation. so that these will cancel, and I've got 5 equals 4th root of x. So I got the radical term alone. Now I need to take the appropriate power. Again, 4th root is really like a 1/4 power, so the reciprocal of that is 4 over 1. So I'm going to take both of these to the 4th power. So I'm going to put parentheses around the whole thing, which indicates everything in there gets that 4th power. So on the left side, I'm going to do 5 to the 4th. On the right side, the 4th root and the 4th power cancel, so all I have left is x. So x is going to equal to 5 to the 4th power. So if you want to use your calculator to help you out with that, if you don't know, x equals 625. Now, before I circle or box or whatever we do with our answer, you have to check it. Put it back into the original and make sure it works. So for my check, I just say 5 minus 4th root of 625. You can punch that into your calculator, and we just want to know, does that indeed equal 0? Because that's what it says it does in the equation. So if you punch that in, you will get 0. We've checked it, so 625 is a valid solution for our problem here. Let's look at B. Again, I have a single fractional exponent, so I need to get it alone first. Remember, only this has the fractional exponent, which means I need to get rid of that 3 in order for this term to be alone. So first thing I'm going to do is divide by 3 on both sides. So then I've got x to the 4/3 equals 243 divided by 3 is 81. So x to the 4/3 equals 81. Now that my fractional exponent is alone, I now take the appropriate power. Remember, the powers should be reciprocals of one another. So this is 4/3. The reciprocal of 4/3 is 3/4. So I'm going to take both sides, everything in here, to the 3/4 power. Again, the whole purpose of that over here, if you multiply those exponents, you get x to the first. So just x, so x is alone. Over here, I have to take 81 to the 3/4 power, which again means 4th root of 81 to the 3rd if we translate the 3/4 into radical notation, which seems to make the most sense for most people. So 4th root of 81 is 3. So I've got 3 to the 3rd power, which means I've got x equals 27. Again, before I can check it off, I need to make sure that I check it and actually make sure it works. So 3 times 27 to the 4/3 power, I want to make sure that that indeed equals 243. So cube root of 27 is 3. 3 to the 4th is 81. 81 times 3 is 243. So x equals 27 is valid. We can go ahead and box it off. All right, moving on to C here. Again, just one radical term, in this case fractional exponent. Do not try to distribute anything. We're just trying to get rid of this. So the radical term is already alone here. So that means I can go ahead and just take the appropriate power on both sides. The reciprocal of 1/2 is 2. So I'm going to square both sides. So on the left side, the 1/2 power and the second power cancel. So I've got 2x plus 5 by itself. On the right side, 4 to the second power equals 16. So now, very easy equation to solve. Subtract the 5. 2x equals 11. Divide by 2. And x equals 11/2. So I'm going to check it out. Remember that a 1/2 power is really a square root. That seems to make more sense to a lot of people. So I'm going to plug in my 11/2. Make sure that this works. I want to make sure I get 4. So 2 times 11/2 is 11. 11 plus 5 is 16. The square root of 16 is 4. So I've got to check there. 11/2 does work. All right, next one, very similar to C, except that it's written from the beginning in radical notation. The radical is already alone, so I'm going to go ahead, appropriate power both sides, which is squared. So the square root and the squared undo each other. I've got 2x plus 4 over here. Over on the right side, negative 8 squared is positive 64. Remember that if you don't know that off the top of your head and you're trying to use your calculator, you have to include the negative 8 in parentheses. Anytime you square something, it should be positive. So now to solve, subtract 4. So 2x equals 60. Divide by 2, and x is 30. Now I'm going to do my check. So I plug my 30 back in, 2 times 30 plus 4 equals negative 8. So 2 times 30 is 60, 60 plus 4 is 64. Square root of 64 equals negative 8. Now, when we solve equations, we do the plus or minus. We do not do plus or minus when we are checking expressions. And here, square root of 64, unless you have an x equals, which we don't right here, is always the positive. So 8 does not equal negative 8, which means that this one, the only solution that we got, did not work. So in this case, there is no real solution for this problem. All right, let's look at E. Again, I've only got one radical term. So that means I'm going to take the appropriate power on both sides first. So since this is a square root, the appropriate power is to square. Now, do not be tricked over here on the left. This is a binomial. When you square a binomial, I hope that you know by now that that has to be FOILed. Do not just square the x and square the 2. So first x squared, the outsides, because it's x plus 2 times x plus 2, would be 2x. The insides are 2x, and the lasts are 4. Over on the right side, the square root and the squared undo each other, so I've got 5x plus 10. So now, this is a quadratic. Not quite as easy to solve as all the other ones we have, but we should know how to solve quadratics by now. We need to get it all to one side, set it equal to 0 to start with. So I'm going to move these over here, so minus 5x to cancel these, minus 10, cancel those. So I've got x squared, this is a plus 4, and this is a minus 5, so that gives me minus 1x. 4 minus 10 is negative 6 equals 0. Now, lots of ways to solve quadratics. If it's factorable, I would go with that first. If not, then complete the square or use the quadratic formula. This one is factorable. We do know factors that multiply to negative 6 and add to negative 1. That'd be negative 3 and positive 2. So that means it's x minus 3 times x plus 2. So set them each equal to 0, x equals 3, and x equals negative 2. Now, on my check, you've got to check both of them. So plug it in. On the 3, I get 3 plus 2 equals square root. 5 times 3 is 15, plus 10 is 25. So is 3 plus 2 equal to the square root of 25? Yes, it is. Try the negative 2. Negative 2 plus 2 equals square root. 5 times 2 is 10, or 5 times negative 2 is negative 10, plus 10 is 0. Negative 2 plus 2 is 0. Square root of 0 is 0. So both of these work. 3 and negative 2 are both good solutions. All right. So I did 5 examples where we only had a single radical term. Now, the last 2 examples are the other type. We have 2 different radical terms. So we have to get them on opposite sides of the equals. The reason is, If I try, and I'm going to move this down a little bit just to show you. If I tried here, because I see that these are square roots, if I tried to simply square both sides how they are, so if I left it like this and tried to square this side and square this side, over here, remember that this would be a binomial. You would have to FOIL that, and the inner and outer terms would still have radicals. So that is why we have to get them on opposite sides to solve them. So I'm going to write that here. So hopefully when you're going back to look at your notes, you remember whenever there's two, you've got to get them on opposite sides. So the first thing I'm going to do is move this one over by adding. So add 2 radical x to both sides. Now that the radicals are on opposite sides, I can take my appropriate power because I'm not going to have to worry about foiling. So opposite of square rooting is to square. So when I square this, radical drops out. On the right side, remember you have to square both parts, not just the radical. So 2 squared is 4. Radical x squared is just x. So now I've got 12 minus 2x equals 4x. Again, that one's very easy to solve. Add the 2x to the other side, so 12 equals 6x. Divide by 6, and x is 2. As always, and notice I've done it on all of these, I need to check. So to do my check, I'm going to plug it into the original. So square root of 12 minus 4 is what it would be, minus 2 radical 2 equals 0 is what I'm checking. So square root 12 minus 4 is 8. So square root of 8 is, in simplified form, 2 radical 2. So 2 radical 2 minus 2 radical 2 is indeed 0. So x equals 2 is a valid solution. All right, we made it. Last example here. Again, look, 2 different radicals. So we need to get those on opposite sides. So first thing I'm going to do is subtract this to the other side. So I've got 4th root of 2x on the left and negative 4th root of x plus 3 on the right. So now, appropriate power both sides. Notice they have the same radicals. So the appropriate power for a 4th root is a 4th power. So on the left, 4th root and the 4th power cancel out. I've got 2x. Over on the right side, don't forget this negative 1 in front. Negative 1 to the 4th power is positive 1. So this is going to become positive over here. With this part, the 4th root and the 4th cancel out. So I've just got positive 1 times x plus 3, which is just x plus 3. So now again, look, very easy. Basic pre-algebra equation to solve. 2x minus x is x, and I've got x equals 3. So now plug it in. To do my check, 4th root of 2 times 3, so 4th root of 6, plus 4th root of 3 plus 3, which is 6, equals 0. Well, 4th root of 6 plus 4th root of 6 is 2 4th roots of 6, which does not equal 0. So this does not check out. So that means that this one also has no real solution. Now, I do want to point out one last thing. When you get multiple solutions like we did here in E, sometimes one of them will check out and the other one won't. So if you get multiple answers and I've only got one listed, it's usually because the one of them did not work when you plugged it back in. So please, 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 just because one works doesn't mean they both will. Check every single time to make sure your answers work. And that is it.